What's up, guys and gals? It's Coach Goo back again with another fun-filled, action-packed, flipped geometry classroom video. So today, remember back, we had that unit where you're trying to prove that two triangles are actually congruent using things like angle, 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 side, angle, 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 side, not ASS. Well, now we're going to do the same thing with triangle similarity. We're going to try to prove that two triangles are actually similar. That means there are perfect ratios between the two triangles, but maybe they're not the same size. So let's look at the three different ways that we can prove that two triangles are actually similar. So the first way is angle, angle. If we can prove that two corresponding angles are congruent between two triangles, then the two triangles are similar. So let's show you some examples at work. So look at numbers 1 and 2. This is for angle, angle similarity. We're trying to prove that two angles between the two triangles are in fact congruent. And then we need to write a similarity statement if they are. So look at number 1. This one's very clear for you. So angle A is 75 degrees. Do I see a 75 degrees in the other triangle? Yes, I do. That's angle D. Wait, but they didn't tell me what the third angle was. However, if angle A is 75 and angle B is 74, well, let me subtract those from 180. Let me add those together. 74 plus 75. That's going to be 74 plus 75. That's going to be 149. And if I subtract that from 180, 180 minus 149, then 31 degrees is what I'm left with. So I would find out that angle C is 31 degrees. Now, do I see a 31 degrees on my other triangle? Yes, I do, right there, angle F. So now I've proven that two pairs of angles are congruent. That means these two triangles are similar. So let's write a similarity statement. So triangle ABC, and yes, it does matter, is similar to triangle, where's A, D, and then our C is congruent to F, so C needs to be last, so F needs to be last, D, E, F. And that is my similarity statement. Now look at number 2. On number 2, they're showing us that we have one pair of congruent angles. See, there's one pair of congruent angles. Then, do you see any other angles that might be congruent? Remember, we're looking for two angles. So, if you look right here in the middle, bam, these are vertical angles, remember? When it makes a cross section, bam. The ones that are right across from each other are always vertical, which means they're congruent. So we do have two congruent pairs of angles here. So triangle, let's start with V, then to X, then to W, is congruent to triangle. If we started at V, that's congruent to Y, that's congruent to angle Y, then to X, then to Z. And there it is. So that's how you use the angle-angle similarity to show that two triangles are similar. Next up, side-side-side similarity. So if all corresponding sides are proportional, every single pair of sides has the exact same similarity ratio, then the triangles are similar. So let's show you this at work. Look at numbers 8 and 4. These numbers are really weird. Okay. 8, we can see that our numbers are 3, 4, and 5, and this other triangle here is 6, 8, and 10. So let's see what the ratios are. So 3, and that's going to be, we think, it's going to be similar to this side, 3 over 6. And now let's look at our other sides. We've got 4, and this would be corresponding to the side over here, so 4 over 8. And lastly, we've got this side over here, that's QR5 over this side right here, 10. Now, are all of these ratios the exact same? Well, if I reduce 3 over 6, that can be reduced to 1 over 2. 4 over 8, that's the same thing as 1 over 2. 5 over 10, that's the same thing as 1 over 2. So yes, all the ratios are the same, which means that we have side, 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 and these are indeed similar triangles. So triangle QPR is similar to triangle TSU. There you go. Now let's look at number 4, and we're going to do the exact same thing. So First off, we've got BAM right here. DC looks like it's should be. It's corresponding to GF, so 30 over 24. Then we've got, let's pick another side, DE, 35 over 28. And lastly, we've got BAM over that, 32 over 25. Now let's see if all of these are the same. And now one way you can check it very simply, if you don't know how to reduce, is plug it into the calculator and see what decimal that gives you. So for example, if I put 30 over 24 into the calculator, it gives me 1.25. 1.25. Now if I put 35 over 28 in the calculator, 35 over 28, that is 1.25. Okay, looking good, looking good. Now 32 over 25 in the calculator, 1.28. Oh my goodness, it's not the same. That means that all three sides are not the same ratio, which means that no, these are not similar triangles. All right, and now onto the last one, side angle side. So in this situation, if we can prove that two corresponding sides are proportional, and then the included angle is congruent, then the triangles are similar. Okay, so we need two sides with the exact same ratio, and then the angle in between those two sides needs to be the exact same. So let's look at how that works in examples 5 and 6. So look at number 5. They're giving us one side right here. That's 8, and that's corresponding to this side, so 8 over 6. And then we've got this other side over here, KL and NP. That is 20 over 15. All right, now first let's make sure these ratios are the same. So 8 over 6 equals, divide by 2, 4 over 3. 20 over 15, if I divide both numbers by 5, it's 4 over 3. So that checks out. Both those sides have the exact same ratio. Now, they tell us that this angle in between on both of the triangles is congruent. That means we've got angle, no, wait, what? We've got side, angle, side. So this these are, wow, I'm like totally stuttering today. These are congruent triangles, yes. I mean, wow, these are similar triangles, yes, and its triangle JKL is similar to triangle MNP. Boom. There you go. All right, and last up, number 6. So let's take a look at these two triangles. We've got, here's one of the triangles, and then the other triangle is this triangle. Whoa. Okay, so let's take a look at the ratios first. We've got 15 over 25. See that? 25, and that's going to reduce to, if I divide by both numbers by 5, that's 3 over 5. And now this other side over here is 12 over 21. And that, if I divide both numbers by 3, is 4 over 7. And so we can see that the ratio already between these two sides is not the same. So no, we cannot prove that these two triangles are similar. So right here you can see that both triangles have the same angle. So, you know, we have a side, we have an angle, but the second side is not the same, guys. It's not the same. Right, now let's move on into some more examples. We're going to actually do some work here proving triangles are similar. They give you a hint on each of these. They're telling you, can you prove that the triangles are similar by angle on this first section. So I'm going to do number, let's do number 2. Let's just switch it up. Let's start with number 2 here. We've got two triangles, bam, right there. And then the other triangle is right here. That's just the illustration, okay? Remember, we're looking for two pairs of angles that are congruent. Now, some of you might be like, I don't see anything there. Well, look at this. If I extend, oh boy, your favorite. If I extend this line right here and this line right here, note that both of these lines are parallel because of those triangular marks. Well, I have a transversal, oh my goodness, the vocabulary words running through these two lines right here at ML. Wow, it's the same color. Okay, whatever. Anyways, that means that this angle right here and this angle right here are corresponding angles. That means they are congruent, okay? So I found one pair of angles, but can I find another one? Look at this line over here. It's also a transversal running through these two lines. And that means that these two angles are here. 1, 2. It's congruent to this angle right here. So now, look at my picture again. Do I have two pairs of congruent angles? Yes, I do. So that means I have enough to prove by angle that these two triangles are indeed similar. So we need to write a statement. So triangle LPQ is similar to triangle LNM. Bam! There it is. Okay, you guys do number 1 on your own. Moving on. Down here, side, side, side. So, I'm going to do number 7 with you guys. One, on side, 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 all we're doing is making sure that all the ratios are the exact same. So, let's look at the similar, but you have to make sure that the sides are corresponding. So, for example, look, KN, that's corresponding to this side right. Which one is this one? Over here, boom. These two sides are corresponding, so it's going to be 9/14. Now, does that also, which another pair? We got 13.5 over this bottom part right here, 21. 13.5 over 21, and then lastly we got 27. That's the longest side, so it's going to be congruent to this. It's going to be corresponding to this longest side, so 27 over 42. Now we're going to see if all of these are the same, probably using the calculator because there's a decimal in there. So 9 divided by 14 is 0.642, 13.5 divided by 21 is the same number, 0.643. And now 27 divided by 42 is the same number, 0.643. So yes, the ratio is all the same. That means yes, these are similar triangles. So I got to write a statement. Triangle K and R is similar to triangle. If I started at K, it's going to be D, then to N, so to DES. Triangle KNR is similar to triangle DES. Are you guys due? Number 8 on your own. And lastly, over here, side, angle, side. So we're looking for a side, an angle in between, another side. So let's take a look. Let's do number 13. So remember, the angle has to be included between the two sides. So first of all, let's look. We can already see that here's this two sides right there, and here are two sides. The angle needs to be in between the two. So it's going to have to be this one and this angle. Are those two angles congruent? Yes, they are, because they are vertical angles. So we've already taken care of our angle. Now all we have to do is check that the ratio of the sides is the exact same. So the corresponding sides, SE corresponds to side GE, actually. So make sure you don't confuse yourself. So that's going to be 12 over 48. And if I divide both these numbers, it's going to be, if I divide by 12, it's going to be 1. If I divide 48 by 12, it's going to be 4. Then the other corresponding side is this side ER and EF. So it's going to be 6 over 24. If I divide 6 by 6, it's 1. If I divide 24 by 6, it's 4. Boom! Two of my sides, the ratio is the same, and I have a congruent angle in between the two sides. So the answer is going to be yes, they are similar, and triangle SER is similar to triangle GEF. And there it is. So you guys try number 14 on your own, and that is going to conclude this note section about angle, side, and side, triangle similarities. So until next time, I will catch you guys later in the next one. Peace.